Subject structural analysis 2, and the title of this topic is today's topic is analysis of building frame. For the analysis of the building frame, there is two types of the method. The first one is approximate analysis, then second one is exact analysis. There is three method for the approximate analysis. The first one is the analysis of the vertical load of the building frame, and second one is the analysis of the horizontal load of the building frame. For the analysis of the horizontal load in the building frame, there are two types of method. The first one is portal method and the second one is cantilever method. In case of the exact analysis, there is two types of the method. The first one is force method and the second one is displacement method. We have to know the practical application of the approximate analysis of the building frame. The first one is preliminary design. In preliminary design, the approximate analysis method can be used during the preliminary design phase of the building project. These methods provide the approximate result for the structural force, displacement and deformation, which can help engineer in making the preliminary design decisions such as selecting the appropriate member size and evaluating the feasibility and stability of the structure. That is preliminary design. The second one here, to compare the different design options. It means feasibility study. The engineer can use the approximate method to quickly compare the different design options and assess their performance in terms of structural stability, cost effectiveness and constructability. The approximate analysis provides the quick estimation of the seismic force and deformation. It means seismic design, which add in seismic design. Here is example 1, the approximate analysis for the vertical load of the building frame. In here, we will analyze only the vertical load of the building frame, okay? There is not any horizontal load because the girder and the column are rigidly connected. That means that can withstand the load from the earthquake, wind, etc. Let's say in this one is girder, this one is column, okay? In girder, there is a 4 kilonewton per meter of uniformly distributed load, and the internal girder has the 6 kilonewton per meter, and there are the 6 kilonewton per meter. Okay, and the span between this girder is 3 meter, and 4 meter, and the distance between the bay is 4 meter, 6 meter, and 3 meter. Okay. Our first step is to make some assumption. Here, for the analysis of the vertical load of a building frame, we have to make some assumption. Here is 3 assumption. The first one is the axial force in the girder is 0. There is not any axial force in the girder. The second and third assumption is there is point of inflection at a point of 1/10 of the span from the left or right of the support. Okay, let's first apply the assumption here. Our first step is to apply the assumption to be made. Okay, In second and third assumption, there is a point of inflection at a point of at a distance of 1/10th of the span from the both left and right support. Okay, this one is left support. That means we have to put the point of inflection. This one is left support. We have to put the point of inflection from that 1/10 part. Okay, let this one is 1/2 part. Same like this from the right part too. Same here 1/10 part. And we have to write here the distance. Okay, 1/10 of the how much is span? Let's see here this span distance is how much? Let's see 4 meter. Okay, 4 meter, 6 meter and 3 meter. That means 4/10 how much? 0.4 0.4 0.4 meter. How much remain? 0.4 0.4 মানে 3.2. Okay, just like this, calculate all the distance here. Just divide the total span by 10 and you will get all the values. Okay, how much? 6, right? 6/10 means 0.6. This one also 0.6 and this one is 4.8. Okay, this one is 0.3. Total span is 3 meter. That's why 3/10 0.3 meter. 0.3. How much remain? 2.4. Okay, all values are same here. Just fill up 0.6, 4.8, 0.6, 0.6, 4.8, 0.6. In here we are taking the part of this frame, that means order AB. We expand it and this one is point of inflection and the distance of the point of inflection from left and right support is 0.4 meter and 0.4 meter and the middle portion is the span of the middle portion is 3.2 meter. Okay, we have to calculate the bending moment here and here. Okay, because this support is fixed support, this one is also fixed support. Okay, that means the girder is rigidly connected with the column. That's why this one is fixed. If there is fixed support, moment will occur. We have to calculate the moment at A and moment at B. For the calculating the moment at A, we have to use the shortcut formula. Okay, 0.045 into WL square for this part only. Okay, this part, small part only, not for the middle part. Okay, the middle one is simply supported beam with UDL. That means bending moment will be WL square by 8. That's why we have to calculate the only small part. Okay, the shortcut formula is 0.045 into WL square. Here calculate 0.045 into W. Intensity of load is 4 into total span, not 0.4 meter. Okay, whole total span. That means 4 square. How much value? 2.88. That means 2.88 kilonewton meter. The value of the bending moment will be the 2.88 kilonewton meter. Okay, and in similar way we will calculate the bending moment diagram at B. This will be also 2.88 kilonewton meter. We calculate the bending moment value of this A point and B point, 2.88 kilonewton per meter. I think you have the confusion how this direction is downward. Do you know? I will explain. Okay, see here, only take this part. Okay, And you know one thing, here and here, how much force will be generated? Reaction force 4 into 3.2. Okay, 4 into 3.2 divided by 2. 4 into 3.2 is equal to divide by 2. How much? 6.4. That means this force is how much? 6.4, and this also 6.4. And this will also act in downward direction, and this will also act in downward direction, 6.4 kilonewton. Okay, let's take this part only. Okay, I will show you the direction, why this direction is downward. See here, this one is hinge, and there is a load, how much? 0.4, and this one is 4 kilonewton per meter, and the distance is 0.4 meter, and we have to calculate the bending moment here, right? Let's say the okay, we are letting, right? Let's say this direction is clockwise, let's say M. Just see here, we are taking the moment here. This one is clockwise, take negative. Okay, negative. And this one is, this should act in downward direction, that means anti-clockwise. Okay, positive. 4 into distance, how much? 0.4. Force into perpendicular distance, the UDL acting half of this one, 0.2. There is one force of 6.4 kilonewton per meter. There is a one force acting downward, 6.4 kilonewton. Okay, reaction force. It also acts in downward direction, that means direction will be anti-clockwise, positive. 6.4 into 0.4 is equal to 0. We get the value of M is equal to 2.88. That means our assumption is right. The direction is clockwise. Okay. Let's see here too, why this direction is downward. Let me explain. Okay. Here is downward force of 6.4 kilonewton, and here is UDL 0.4. Let's see here. Okay, we are calculating the bending moment here. This direction is clockwise. Okay, say we don't know the direction of this moment, clockwise or anti-clockwise. We are just assume as clockwise. In left part, clockwise positive. Okay, this means clockwise positive, M plus this is also act in downward direction, that means direction will be the clockwise. 4 into 0.4 into 0.2, distance force into distance. This act also in downward direction, that means 6.4 into 0.4 is equal to 0. We get M is equal to minus 2.88 kilonewton meter. We assumed the direction of the bending moment at A is equal to clockwise, but we get the value of negative, that means our assumption is wrong. That means we have to change the directions, means its direction will be the anti-clockwise. Okay, that means in this direction, that's why this one is downward. Now we will analyze the another part of this frame, that one is CD. Let's see here, CD. Okay, CD. Here is point of inflection, direction will be same. Okay, downward. I will calculate this value. We'll use the shortcut formula. 0.045 into intensity of load is 6 kilonewton per meter. 6 into WL squared. Span is how much? 4 square. 0.045 into 6 into 4 square. 4.32. This value will be 4.32 kilonewton meter. This will be also 4.32 kilonewton meter. Okay. Like in similar way we can calculate the every part of the frame.